Have you ever gazed up at the night sky and wondered how stars change over time? Picture the twinkling points of light in the night sky, each one a star. But did you know that not all stars are the same? Some of them, like our sun, are in their middle age. Others are in their twilight years, becoming what we call red giant stars. These celestial bodies are not just static points of light. They're dynamic, changing, and evolving in ways that are both dramatic and fascinating. The life cycle of these stars is a cosmic dance of transformation that has intrigued scientists and stargazers alike for centuries. From their birth to their eventual death, red giants are a testament to the ever-changing nature of the cosmos. Today, we're going to unravel some of the most fascinating facts about red giant stars that you might not know. So get ready, because we're about to embark on a stellar journey. Imagine a star, much like our own sun, but nearing the end of its life. This stage is a pivotal moment in a star's life cycle, marking the birth of what we call a red giant. But what exactly brings about this dramatic change? Let's delve a little deeper into the cosmic tale of transformation that stars undergo. Every star begins its life as a giant cloud of gas and dust. These particles start to pull together under gravity, forming a dense core. The core then heats up, kickstarting a process known as nuclear fusion. In this fiery heart of a star, hydrogen atoms are squeezed together to form helium, releasing vast amounts of energy in the process. This energy, in the form of light and heat, is what makes a star shine. However, this hydrogen fuel doesn't last forever. After billions of years, a star will exhaust its hydrogen supply. But this doesn't mean the star's story is over. Quite the contrary, in fact. The core of the star starts to contract, and the temperature within it rises. This high temperature triggers a new phase of nuclear fusion, where helium atoms are now fused together to form heavier elements like carbon and oxygen. As this fusion process continues, the outer layers of the star expand and cool down, giving the star a reddish appearance, hence the term red giant. This phase of a star's life is characterized by its swollen size, cooler temperature, and intense brightness. Meanwhile, the core keeps contracting and heating up, preparing for the next phase in the star's life. This cycle of expansion and contraction, of heating and cooling, is a testament to the dynamic and ever-evolving nature of stars. So the red giant phase is not the end, but rather a dramatic transformation in a star's life. It's a spectacular cosmic dance, choreographed by the laws of physics and played out over billions of years. Yet this is just the beginning of the story, as the star prepares for its next even more fascinating stage. Can you comprehend how vast a red giant star can become? It's a question that can truly boggle the mind. These celestial behemoths in their prime can dwarf our very own sun. To give you a sense of perspective, our sun, a typical star, is about 1 million miles in diameter. Now imagine a star expanding to 100 times its original size. That's a red giant for you. So what does this expansion mean in real terms? Well, if our sun were to become a red giant, its outer edge would extend beyond the orbit of Earth, swallowing our planet whole. The sun, as we know it, would be transformed into a massive glowing orb, so large that it would engulf all the inner planets of our solar system. It's a humbling thought, isn't it? Now you might be wondering, how does a star get so large? The answer lies in the heart of the star. As a star ages, it burns through its hydrogen fuel. Once this fuel is exhausted, the star begins to collapse under its own gravity, causing the core to heat up. This increased heat triggers the outer layers of the star to expand dramatically, transforming the star into a red giant. And the size of these red giants, they're not all the same. Some red giants are 100 times larger than our sun, while others are several hundred times larger. The largest red giants, known as red supergiants, can reach sizes over 1,000 times that of our sun. That's so large they could swallow up the orbit of Jupiter. Despite their massive size, red giants are not the end of a star's life cycle. They are but a brief, albeit spectacular stage in the life of a star. After the red giant phase, stars continue to evolve, eventually shedding their outer layers and revealing their cores, becoming white dwarfs. In this expanded state, a red giant truly lives up to its name. A gigantic glowing red beacon in the night sky, a testament to the immense power and the fascinating journey of stellar evolution. What do you think happens at the core of a red giant? Well, the answer to that question takes us into the heart of these celestial behemoths, where a fascinating process is taking place. You see, the core of a red giant is home to a process known as helium fusion. This is a stage in the star's life when it has exhausted the hydrogen at its core and the helium that was produced during hydrogen fusion starts to ignite. This helium fusion is a remarkable process, and it's not something that happens overnight. It takes millions upon millions of years for this process to take place. But the result of this incredibly slow and powerful process is the creation of heavier elements, specifically carbon and oxygen. Yes, you heard it right. The very elements that are critical for life on Earth are being forged in the fiery crucible of a red giant's core. This process, known as nucleosynthesis, is how elements heavier than helium are created in the universe. But the creation of these elements isn't a gentle process. Far from it. The fusion of helium into carbon and oxygen generates an immense amount of pressure and heat. We're talking about temperatures of hundreds of millions of degrees, and pressures billions of times greater than what we experience on the surface of the Earth. It's in these extreme conditions that carbon and oxygen are formed. And it's not just about creating elements. The energy released during helium fusion also helps to support the star against the force of gravity, preventing it from collapsing in on itself. This energy is what makes the star shine brightly in the sky, a beacon in the darkness of space. So, the next time you look up at the night sky and marvel at the beauty of the stars, remember this: the heart of a red giant is a fiery furnace, creating elements essential for life as we know it. What becomes of a red giant after its helium fuel is exhausted? A question that leads us to the next intriguing chapter in the life of a red giant: the formation of a planetary nebula. Imagine the star, once a blazing furnace, now sputtering out its final breaths. It's an intense, dramatic process, a celestial swan song that is anything but quiet. The star, now a red giant, has exhausted its helium fuel and its core begins to contract under its own gravity. Yet even as the core shrinks, the outer layers of the star expand, growing larger and larger, eventually being thrown off into the surrounding space. This is the birth of a planetary nebula. But don't let the name fool you. These have nothing to do with planets. The term is a relic from the early days of astronomy, when these glowing gaseous shrouds were observed through telescopes and mistaken for planets. As the star sheds its outer layers, these layers are heated by the hot core, causing them to glow. The result is a vast cloud of gas and dust illuminated from within, creating a spectacular light show. The colors we see in these nebulae are real, a result of the different elements being excited by the intense heat of the core. But what of the core itself? Well, that's where things get really interesting. The core, now bare and exposed, is what we call a white dwarf. But we'll delve into that in the next scene. So, the life of a red giant, as grand as it is, ends not with a whimper, but with a radiant, glowing testament to its past life. The outer layers, once part of the star, now form a beautiful, glowing nebula, a celestial work of art painted on the canvas of the cosmos. The death of a red giant gives birth to one of the most beautiful phenomena in the universe, a planetary nebula. A fitting finale, wouldn't you say? But remember, this isn't the end of the story. It's just another chapter in the fascinating life cycle of a star. So, what remains after a red giant has shed its outer layers? As the curtain falls on the red giant's grand performance, it leaves behind a hot core, a remnant of its once vibrant self. This core, deprived of nuclear fuel and subjected to the relentless pull of gravity, begins an incredibly long journey of cooling and contracting. This is the final stage in a red giant's life cycle, a stage we know as the white dwarf. The white dwarf is a fascinating celestial object, a testament to the inevitable end of all things, even stars. It's a dense, compact star, about the size of our Earth, but with a mass comparable to that of our Sun. Imagine an object so dense that a teaspoonful would weigh as much as an elephant. That's a white dwarf for you. Most of the star's original mass is packed into this tiny volume. As a result, the white dwarf is extremely hot when it's born, with a surface temperature of over 100,000 degrees. However, without any nuclear fuel to maintain this heat, it begins to cool down slowly. This cooling process doesn't happen overnight. It takes billions of years for a white dwarf to cool down and fade away. During this time, the white dwarf continues to shine, not due to nuclear fusion, but because of the residual heat from its previous life as a red giant. But the story doesn't end there. For some white dwarfs, there's a chance for a dramatic encore. If it's part of a binary system and its companion star expands, The white dwarf can start drawing matter from its partner. Once it gathers enough material, a spectacular explosion called a supernova can occur. Even in its death, a red giant continues to shine, albeit in a different form. Whether it's quietly cooling down as a white dwarf or going out with a bang as a supernova, the story of a red giant's life is a compelling tale of transformation and endurance, a tale as old as the universe itself. Isn't it amazing how a single star can undergo such dramatic transformations? We've journeyed through the cosmos today, unraveling the mind-boggling mysteries of red giant stars. Let's take a moment to recap the celestial spectacle we've discovered. Imagine a star, much like our sun, reaching the twilight of its life. As it exhausts its hydrogen fuel, it begins to swell, expanding to an immense size. This is the birth of a red giant star. The heart of the star, its core, contracts and heats up, while the outer layers balloon out, transforming the once moderate star into a celestial titan. The core of a red giant is a crucible of creation. Here, helium fuses into carbon, releasing energy that causes the star to pulsate and shimmer in the darkness. The star's surface, now cooled and reddened, gives the red giant its iconic scarlet hue. Then comes a phase of shedding and renewal. The outer layers of the red giant are cast off, creating a mesmerizing spectacle known as a planetary nebula. This isn't an end, but a glorious transformation. What remains of the star then contracts into a dense, hot core, a white dwarf. Despite its name, this star is anything but feeble. It shines with an intense light, the final testament to the once mighty red giant. Even in its death throes, the star continues to dazzle the cosmos. As we've seen, the life of a red giant star is a journey of constant change and spectacular events. From the star's fiery birth, through its expansion and shedding of layers, to its ultimate transformation into a white dwarf, each stage is a testament to the incredible forces at work in our universe. Next time you look up at the night sky, remember the incredible journey of red giant stars, from their fiery birth to their brilliant end. We hope you've enjoyed this incredible journey through the cosmos, discovering the life of red giant stars. If you've learned something new today, why not give this video a like? Your support helps us continue to unravel the mysteries of the universe. And we'd love to hear your thoughts on this celestial spectacle. Do you have any questions or perhaps some fascinating facts to share about red giants? Leave a comment below and let's continue the space exploration together. Remember, every star in the night sky has a story to tell, and there are countless more waiting to be discovered. If you're as captivated by the cosmos as we are, don't forget to subscribe and hit the bell icon. This way, you won't miss any of our upcoming cosmic adventures. And finally, if you think your friends or family would enjoy this stellar journey, don't hesitate to share this video with them. The universe is vast, and there's plenty of space for everyone. Until next time, keep looking up and let the stars guide your curiosity.